Yeah, so basically, the first part that I'm going to start today is called as moments. Okay, so in our syllabus, we have something which is called as central moments. Okay, central moments. Okay, so these are called as, this is not given in the textbook, deviations from the mean. Deviation meaning difference, differences from the mean. Okay, so central moments we have. Okay, copy this. You can copy parallelly. Okay, so ungroup data. Ungroup data, which is frequency less. Okay, that means there is no frequency over here. And we are having group data. We are having group data and ungroup data. Group data has frequency for every observation. So the formula over here is mu r. This is called as mu r. Okay, equal to summation x minus x bar. Now this is not modulus. This is a bracket raised to r upon n, where r is equal to 0, 1, 2, 3, 4 dot dot dot. R is equal to 0, 1, 2, 3, 4 dot dot dot. And here mu r is equal to summation f into x minus x bar raised to r upon summation f, where r is equal to 0, 1, 2, 3, 4 dot dot dot. Okay. So that these are deviations, that is differences from the mean. How the data is changing with respect to mean. We are taking mean, and how the data is changing with respect to the mean is nothing but moments. Okay. Now let us take two examples. One is of group data and the other one is of ungrouped data. Okay. So let us go to exercise 14.7, page number 723. Page number 723. Okay. Of your textbook. I hope everybody has copied this. Yeah. So exercise 14.7. Question number 1. Sub question 2. Find first four central moments. They're asking you central moments. They're asking you central moments. Okay. 4, 6, 7, 10, and 13. 4, 6, 7, 10, and 13. Okay. Now this is ungrouped data. There is no frequency over here. N is equal to 5 because there are 5 observations. Because there are 5 observations, N is equal to 5. Okay. X bar, which is the mean, which is also called as the average. Okay. Mean, average, is equal to summation x upon n. So 4 plus 6 plus 7 plus 10 plus 13 upon 5, which is equal to 40 upon 5. That is 8. X bar is equal to 8. Okay. Now the formula. mu r summation x minus x bar raised to r upon n. Now they are asking you first four central moments. First four central moments. So you have to start taking the values of r from 1, not from 0. Yeah. Okay. So take r as 1, 2, 3, 4. You have to take r as 1, 2, 3, 4 in the formula. I'm going very slow. Okay. So let us learn how to calculate this. I'm using the same method as that of the textbook so that you people won't get confused. Copy along with me. X 4, 6, 7, 10, and 13.
So why do you take it as 1, 2, 3, 4?
First four central movements, na? That's why.
Okay.
Okay. Yeah. So this formula, put r is equal to 1. So mu 1 summation x minus x bar raised to 1. Raised to 1 means nothing. Upon n. What is n? N is 5. So in this particular formula, I am putting the value of r as 1. Okay. Now summation is besides x minus x bar. You should never mug up what columns we need to make. Never ever do that. That thing is always specified by the formula. Now the formula says summation. Don't call this as sigma. Call this as summation. Okay. So summation x minus x bar. So summation is besides x minus x bar. So wherever there is summation, that particular column will be is supposed to be written. Wherever there is summation, that particular column is supposed to be written. Now x bar we have seen it is 8. X bar is 8. So 4, this is 8, right? So 4 minus 8. Minus 4, 6 minus 8. Minus 2, 7 minus 8, minus 1. 10 minus 8, 2, and 13 minus 8. That is equal to 5. Summation means the total of this column. The total of this column is what? 0. So 0 upon 5, which is equal to 0. Okay, right? Now rest of the problem is quite simple. Take r is equal to 2. So mu 2 x minus x bar. You put r as 2 over here. You put r as 2 over here. Upon n. N is 5. Now I have seen students squaring this particular value, which is wrong. Summation is besides x minus x bar square. Summation is besides x minus x bar square. So what we should do? We should insert that particular column. X minus x bar square. 16, 4, 1, 4, 25. That is 50. Okay. Right. So the final answer over here will be 50 upon 5, which is equal to 10. R is equal to 3. R is equal to 3. Okay. So mu 3. Same formula. Put the value of R as 3. Summation x minus x bar raised to 3 upon 5. Now x minus x bar raised to 3. Summation is besides x minus x bar raised to 3. So cube this values x minus x bar cube. So cube all these values. Okay. Otherwise, you can also multiply x minus x bar into x minus x bar square. You will get the answer. So this is minus 64 minus 8 minus 1, 8 and 125. 60. The total of this will be 6060. So 60 upon 5, which is equal to 12. 60 upon 5, which is equal to 12. Okay. And then R is equal to 4, mu 4, x minus x bar raised to 4 upon 5. You put the value of RS4 over here, RS4 over here. Now summation is besides x minus x bar raised to 4. Summation is besides x minus x bar raised to 4. So wherever there is summation, that column should appear. That column should appear. So if you want to calculate this, it will be simply the square of this particular column. Okay. Yeah. So that is 256, 16, 1, 16, 625. 914. 914. 14. So this is 914 upon 5. 182.8. So these are the first four central movements. These are the first four central movements. Now, few things you need to understand. Why these are called as central movements? Because they are calculated as the deviation. Deviation means difference. Difference from the mean. So they are called as central movements. The first central movement is always zero. The first central movement is always zero. First central movement is always zero. The second central movement is always the variance. The second central movement is always the variance. You have to remember this. Okay? You have to remember this. The next problem will take group data. Okay? We'll take group data. Fine? Yeah. Exercise 14.7. Exercise 14.7, question number 2. So this time x and f is given. Right in the extreme left, x and f. 3, 5, 7, 9, 11, 12. Okay. 4, 3, 5, 4, 6, and 3. Right? Okay. So first four central moments. So mu r summation f into x minus x bar raised to r upon summation f. Okay, summation f. So you have to take r is equal to 1, 2, 3, 4 because you are calculating first four central movements. Now the first calculation over here will be the calculation of x bar. So x bar is equal to summation fx upon summation f. This is frequency based data. In frequency based data, mean is not summation x upon n. Mean is summation f into x upon summation f. Okay. Now summation is besides f into x. So first column we are going to prepare is f into x. F into x. Okay. Yeah. 12, 15, 35, 36, 66, and 36. What is the total? 200. 200. The total is 200 over here. And summation f, the total of the frequency, 25. It is 25. Total of the frequency is 25. Okay. So 200 upon 25, which is equal to 8. Okay. Now R is equal to 1. So mu 1. I'll put the value of R as 1 over here. Summation F into X minus X bar upon summation F. Okay. Right. So what am I going to do? Summation is besides F into X minus X bar. So first I'm going to calculate X minus X bar. Okay. X minus X bar equal to 8. X minus X bar, this column minus 8. 3 minus 8 minus 5. 5 minus 8 minus 3. 7 minus 8 minus 1. 9 minus 8 1. 11 minus 8 3. And 12 minus 8. That is equal to 4. Clear? Yeah. But then summation is besides F into X minus X bar. So we require the total of this particular column. So we are going to make that column F into X minus X bar. Okay. So multiplication of F and X minus X bar. Okay. Yeah. X minus X bar into F. Minus 20, minus 9, minus 5, 4, 18, and 12. What is the total of this? 0. Okay. This is 0. So this is 0 upon 25, which is equal to 0. And as it is, mu1 is always 0. The first central moment is always 0. Okay. Now put R is equal to 2 mu2 summation f x minus x bar raised to 2. You are putting R as 2 over here upon summation f. Summation f is 25. Now how to calculate this particular column? Be very attentive how to calculate this particular column. Now firstly, why this column is required? F into X minus X bar the whole square. Why it is required? Because summation is besides that particular column. Wherever there is summation, that column should appear. So F into X minus X bar the whole square. Okay. Now see how to calculate this. You're going to multiply this column with this column. Because X minus X bar into X minus X bar is X minus X bar the whole square. Okay, so we're going to multiply the two columns which I have marked. F will remain the same, so that is equal to 100, then 27, then 5, 4, 54, and 48. Just verify the values. If there is anything wrong, you can tell me. What is the total? 38. 238. You should sit with your calculators. 238. So 238 upon 25. What is 238 upon 25? 9.52. So this is nothing but V. What is the meaning of V? Variance. The second central movement is always the variance. Now, third central movement. R is equal to 3 mu3 summation f into x bar the whole cube upon summation f. Okay, summation f is 25. Okay, now summation is besides f into x minus x bar the whole cube. F into x minus x bar the whole cube column should be there. F into x minus x bar the whole cube, this particular column should be there. To get f into x minus x bar the whole cube, we'll multiply x minus x bar the whole square, f into x minus x bar the whole square, the blue colored column, okay, into this particular column, x minus x bar, because x minus x bar into x minus x bar the whole square will be the whole cube. So just multiply these two columns. Minus 150, correct? Minus 500, sorry. Yeah. Minus 500, 27 threes are 81, minus 5, 4, 54 threes are 62. Yeah. 162 and 48 into 4. 190. 192. So if you calculate the total of this, minus 228. Minus 228. The total is minus 228. Minus 228. So put this value over here. Minus 228 upon 25, which is equal to negative 9.1. Minus 9.12. This is minus 9.12. Okay. And R is equal to 4. Mu 4. Summation x minus x bar raised to 4 upon summation f. Okay. That's why we had to start from the extreme left over here. Otherwise, the columns will not fit in. Okay. I am putting the value of RS4 here. I'm putting the value of RS4 over here. Okay. Summation F, that is equal to 25. Summation F is equal to 25. Right? Okay. Equal to 25. So we need to prepare that column F into x minus x bar raised to 4. So one last column F into x minus x bar raised to 4, that will be over here. Okay. Try to fit in the information very correctly. Why we are preparing this particular column is because summation is besides f into x bar minus 4. Summation is besides f into x minus x bar minus 4. So x minus x bar the whole cube, this into this. Okay, the two green colored columns. One second. Sorry. This particular column. Yeah, they have to be multiplied. Okay. So that this is 2500 if I'm not wrong. Correct? Then 81 threes are 243. Then this is 5. Correct? 4. This is 162 into 3. 486. And the last one 192 into 4. 768. 8. What is the total? 4006. 4006. Okay. So this is equal to 4006. 4006. Divide this. You will get the answer. 160.24. 160.24. So we have calculated the first four central moments. First four central moments. Now, calculation of moments was very important because in skewness and kurtosis, okay, we will require this. Now, let us understand the next part, that is skewness. Give the topic name as skewness. Okay. The next part is skewness. I hope you understood this calculations. The next part is skewness. So you have to write down quite a lot of things right now and understand as well. Okay. Yeah. Now I'll explain skewness in a very simple language. Okay. Now there are 50 students in a class. This thing is not given in the textbook. It's an example which I am just framing for you. Okay. And I am taking a test. So 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. This is the class and this is the frequency. Between 0 to 10, okay, three students got marks between 0 to 10. I'm taking a 50 mark test and there are 50 students. Okay. There are 17 students who are getting between 10 to 20. Okay. There are 21 students who are getting between 20 to 30. There are 5 students who are getting between 30 to 40 and between 40 to 50. Obviously, there are 4 students because the total is 50 students. This is an example for you to understand. Now, I draw this graph for this particular frequency distribution. This is a frequency distribution, okay? 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay. And this will be 10, 20, 30, 40, 50. Okay. These are marks. Now between 0 to 10, the total is 3. Okay. 1 second. On the x-axis, we have marks. On the x-axis, we have marks. And on the y-axis, we have number of students. So 3 students are getting between 0 to between 0 to 10. 17 students. 17 students between 10 to 20. Between 20 to 30, 21 students. Okay. Just a random rough graph I'm making. Okay. 30 to 40, 5 students. And 40 to 50, 4 students. Okay. Now I'm just taking the midpoint of this bar diagram. Okay. Now I join these points. This is called as a curve. Frequency distribution curve. Okay. This is called as frequency distribution curve. Okay. Yeah. Now skewness, the topic. Okay. And kurtosis as well. In skewness and kurtosis, what we do is like we understand the nature of this curve. We understand the nature of this curve, how the curve is, that we understand using these two topics. Okay, using skewness and kurtosis. Okay, now precisely we will understand what is skewness. I give a random example for your understanding. I just gave a random example. Skewness and kurtosis helps us understand what is the nature of this frequency distribution curve. So I made you understand what is the frequency distribution curve first using an example. Okay, and then I drew one for you, frequency distribution curve, and now I'll make you understand the different characteristics of a frequency distribution curve. This was taken in school like this. Okay, so skewness. If the frequency distribution curve, if the shape is like this, now this you need to copy for your theory. Okay, so this is called as symmetric curve. This is called as symmetric curve because if we divide the curve into two parts, it is exactly symmetric. So symmetric curve always follows normal distribution. Symmetric curve always follows normal distribution. And when the curve is symmetric, mean is equal to median is equal to mode. Mean is equal to median is equal to mode. So this is the first category of frequency distribution curve. Symmetric curve follows normal distribution. Mean is equal to median is equal to mode. Okay. Second, the curve is in this particular manner. So this is not symmetric curve. The second curve is not symmetric. So it is skewed. That means it is not symmetric. These words you need to understand. Okay. So see this particular curve, the example which I had given, this one is also not symmetric. Fine. Yeah. So skewed. Okay. Now the second curve is called as positively skewed curve. This is called as positively skewed curve. Positively skewed curve. Draw these three lines. This is mode, this is median, and this is mean. So for a positively skewed curve, mean is greater than median is greater than mode for positively skewed curve. Here the tail, this region is the tail of the curve. Okay, is longer on right, and the other part of the tail is shorter at the left. Tail is longer at right. Right, all these things, huh? Right as in right hand side. Third one. Third one. Now, obviously, the third one will be negatively skewed curve. Negatively skewed curve. Negatively skewed curve. Okay. So the shape of the curve will be like this. Mean, median, and mode. So here it is. Mean is less than, median less than mode. Tail is longer towards or at left. Tail is longer towards left. Okay. I hope everybody has copied this. So again, this is not a symmetric one. Whenever the curve is symmetric, there is no skewness. So here there is no skewness or zero skewness because the diagram is symmetric. It follows normal distribution. It is also called a standard normal curve. Standard normal curve. Okay. Now measures of skewness. Measures of skewness. First one is absolute measure. Absolute measure. Okay. Okay. So absolute skewness is equal to mean minus mode or mean minus median. Copy this. It can be both. Okay. They can ask you in theory, what if mean is greater than median greater than mode? So it is positively skewed. And if mean is lesser than median lesser than mode, it is negatively skewed. Okay. Right. So absolute skewness, there is one more formula based on quartiles. It is based on quartiles. Q3 plus Q1 minus 2Q2, where Q1 is lower quartile, Q2 is median, Q3 is upper quartile. Q3 is upper quartile. Please copy this. Okay. You need to know this here. Fine. If Q3 minus Q2 is greater than Q2 minus Q1. This implies positive skewness. This implies positive skewness. And if Q3 minus Q2 is less than Q2 minus Q1, this is negative skewness. This is negative skewness. Okay. This was absolute measure. Okay. Second, after absolute measure, a relative measure. A relative measure. First one, Carl Pearson's coefficient of skewness. Carl Pearson's coefficient of skewness. SKP. SKP. Okay. So the formula is SKP is equal to mean minus mode upon standard deviation, or SKP is equal to thrice mean minus median upon standard deviation. Mean minus median upon standard deviation. Thrice mean minus median upon standard deviation. Mean minus mode. Thrice mean minus median. This also you should remember. Mean minus mode is thrice mean minus median. Okay. The second relative measure is Bowley's coefficient of skewness. Yeah, it's there. Bowley's coefficient of skewness. I'll just write it down. Second part, as in the second relative measure, Bowley's coefficient of skewness. SKB. B means Bowley. So this is equal to Q3 plus Q1, the extremes, minus twice the mean. Mean over here is the median. Okay. Upon Q3 minus Q1. So Q3 plus Q1 minus twice Q2. Q2 is the median. So this is the formula for SKB. Okay. Note. First note. SKP equal to 0 or SKB equal to 0. Distribution is symmetric. Distribution is symmetric or symmetrical. That means there is no skewness at all. There is no skewness at all. Zero skewness. Second pointer, SKP greater than 0 or SKB greater than 0. Distribution is positively skewed. I have given you the graph of positively skewed some time back. SKP lesser than 0 or SKB lesser than 0. Distribution is negatively skewed. Distribution is negatively skewed. Distribution is negatively skewed. Second note, you should remember all these theoretical pointers. Second note, first point, if skewness value, whether it is SKP or absolute or relative, whatever it is, okay, lies between minus 0.5 to 0.5. Answer lies between minus 0.5 to 0.5. Distribution is symmetric. Okay. And we should say fairly symmetric. Fairly symmetric. Second part. Second note. When skewness value is between minus 1 to minus 0.5 or 0.5 to 1. Okay. This is negatively skewed. So this is moderately negatively skewed, and this is moderately positively skewed. Moderately positively skewed. Third pointer. The skewness value, if it is less than minus 1, highly negatively skewed, or s greater than 1, highly positively skewed. Okay. It's a long formula list. Next one. Moment coefficient of skewness. Okay. Now this is based on central moments. This is based on central moments. So beta 1 and gamma 1. So this is beta 1 and gamma 1. So beta 1 is equal to mu 3 square. What is mu 3? Huh? Third central moment, correct. Upon mu 2 cube. Mu 3 square upon mu 2 cube. And gamma 1. Gamma 1 plus minus root of beta 1. Gamma 1 is positive. Gamma 1 is positive if mu 3 is positive. Gamma 2 is negative if mu 3 is negative. If mu 3 is negative. Okay. Sign of skewness. Sign means positive, negative. Sign of skewness depends upon sign of mu 3. Third central moment. Sign of skewness depends upon sign of mu 3. Okay. Next, we'll understand kurtosis. Give the topic name as kurtosis. Yeah. So, shape of a frequency distribution curve. Copy this. Shape of a frequency distribution curve can be classified based on shape of the peak of the curve. Okay. So kurtosis is the study of the shape of the peak of the curve. Okay. Right. So yes, frequency distribution curve. This is the normal frequency distribution curve. Okay. So this is called as mesokurtic. Mesokurtic curve. If the peak falls, if the peak falls, this is called as platycurtic. Okay. And if the peak increases, this is called as leptocurtic. Leptocurtic. Please copy this nicely. Gamma 2 is beta 2 minus 3. तो दिया ही नहीं है। ठीक है, मैंने better not given. Yeah. So now some formulae based on this. Some formulas based on this. Okay. Moment coefficient of kurtosis. Moment coefficient of kurtosis. And that's beta 2. That's beta 2. Okay. Beta 2 is equal to mu 4, fourth central moment, upon mu 2 square. Okay. Beta 2 measures the degree of peak. Beta 2 measures the degree of the peak. Beta 2 measures the degree of the peak. Note, hey, there is something which is called as gamma 2, which is equal to beta 2 minus 3. No need to write this, just for your knowledge I am giving you. It's not there in your textbook, okay? Yeah. So, note, if beta 2 is equal to 3, we have mesocurtic curve. The peak is in the center. It's not flat. Okay? The middle one, the red colored one, mesocurtic. Second, if beta 2 is greater than 3, we have leptocurtic curve. Leptocurtic curve. Okay. So this is at the top. The peak is more than that of the mesocurtic. Mesocurtic means normal distribution curve. Okay. The standard curve, where skewness is also 0. And the last one, if beta 2 is lesser than 3, it is platycurtic curve. It is platycurtic curve. Right? Please copy this. So with respect to movements, skewness and kurtosis, movements, problems I have solved, skewness and kurtosis, I have just given you the formula list. Now we will solve the problem. I'll take a 5 minutes break. Then we will resume.